Let's do a few examples of finding the key properties of quadratic functions. So first of all, one property is the shape of a quadratic function's graph, and a quadratic function will always look something like this, and the shape of this graph is a parabola. So we've got a point down here, this is the vertex, and then from there this graph will kind of widen out in sort of a curved shape, and it will head kind of upwards or downwards. So we could have a parabola that faces like this. But one feature is that this parabola would be constantly widening. It never kind of goes back on itself, so we'll never have this curve in like that. Okay, so we've got a parabola, we have a vertex. Other key features would be the zeros of the function, and that would be these two spots here. And these are called zeros or roots, okay, or sometimes called x-intercepts, all the same thing. And then another key feature is the fact that a quadratic function or a parabola is symmetric, and so we have this line down the center, and this is called the axis of symmetry. Axis of symmetry. So notice that that's a vertical line, so its equation would always be something that's x equals some number. Alright, you've got vertex, zeros, these points will always be some number, and then the y-coordinate will be 0, and that's why we call them zeros. Alright, and then your vertex really could be anything, so we'll call that, sometimes the letters that we'll use will be an H and a K. I'm not sure why, to represent the vertex. Okay, so let's look at a couple different forms of the quadratic function equation and try to find some of these key properties from the equation. Alright, so to find the vertex from vertex form, you just need to pick out the numbers, alright, from the equation. So your vertex is, and then remember, I'll just write this up. This is a times x minus h squared plus k. And so if hk is your vertex, then h is whatever's being subtracted from x. So in this case, h is a 2. And then k is whatever number is here at the end of the equation. So in this case, a 3. So your vertex is 2, 3. The axis of symmetry always runs vertically through the vertex, right? So its equation would be x equals, and then that number will always match up with the x-coordinate of the vertex. So your axis of symmetry for this parabola is x equals 2, and I'm getting that 2 from the vertex. Alright, another key feature of quadratic functions is the fact that they always have a maximum or a minimum value. So in this case, for a parabola that opens up, the minimum, or this one would have a minimum value. If your parabola opened down, then it would have a maximum value. Okay, so in this case, we would need to know, is this a maximum or a minimum? And remember that you can tell this from the equation by if the first term is a negative or a positive. So this one is negative, and that indicates that this parabola opens down, and therefore it would have a maximum value. And then that maximum value is just the y value, kind of its height or its function value. So we would say that the maximum value is going to be the y-coordinate of the vertex, so its maximum value is 3. Alright, how about the zeros? Alright, so remember for zeros, we're looking for points where the y-coordinate is 0, and then we're looking to see what the x-coordinate would be. So to do this, I just need to let the y-coordinate be 0, so in this case f of x is always the y-coordinate. Right, so I have 0 equals negative, and then I just rewrite the rest of this equation. Alright, and then to find the zeros, I just need to solve for x. So it looks like I'm going to do this using square roots. So I'll subtract 3, get negative 3 equals negative the quantity x minus 2 squared. Then to get rid of that negative, I'll divide both sides by negative 1. So I'll get 3 equals x minus 2, the quantity squared. And then I will square root both sides to undo the square. Okay, so now I have plus or minus square root 3 equals x minus 2. And then finally add 2 to both sides. So I have 2 plus or minus square root of 3 equals x. Right, so I've got 2 zeros there. I've got 2 plus square root of 3 and also 2 minus square root of 3. Right, if I wanted to write out the whole coordinates, then it's understood that those are the x values. So for instance, 2 plus root 3, and then the y coordinate would always be a 0. Okay. All right, here's one in standard form. So in this case, the y-intercept would be when x is a 0. All right, so in this case, if I plug in a 0 for x, I will have negative 8 times 0 plus 3 times 0 plus 4. And I'm trying to find that y value, or f of x. So these are just going to cancel out, 0 and 0, and that leaves me with a 4. So a shortcut to this would just be realize that those x terms are going to cancel and just leave you with whatever that constant is at the end, in this case a 4. Right, so my y-intercept would be 4, or if you wanted to write this as a point, this would be the point 0, 4. All right, the vertex, you have the formula negative b over 2a, and this is nice for standard form. So in this equation, my b is a 3, so I have negative 3 over 2 times a, which is negative 8. And that's negative 3 over negative 16, or 3/16. All right, so this gives me the x-coordinate for the vertex, and then to get the y-coordinate, I would just need to substitute this back into the equation. All right, so I will do that now. Negative 8 times 3/16 plus 3 times 3/16 plus 4. All right, so that gives, let's see, we can do some canceling here. Let's divide each of these by 8. So that gives negative 2 and 2. Oh, I'm sorry, negative 1 and 2. All right, so that's negative 3 over 2 when I multiply. And then 3 times 3/16, that's 9/16 plus 4. And then if I get common denominators, all right, this would be negative 24 over 16 plus 9/16 plus 64/16, and that's 49/16. Okay, or you could just use a calculator, add all of that together, and then convert from a decimal to a fraction. Okay. So I'll erase that. And then the vertex was 3/16, 49/16. Right? Decimals are okay too, as long as they're exact and not rounded. All right, how do we tell if this one has a maximum or a minimum value? Well, we'll look at the first leading coefficient again, and this one is negative, so this is facing down, and that means it has a maximum value, and the maximum value is just the y-coordinate of the vertex, so the maximum value is 49/16. And then the axis of symmetry, that's your line that runs through the vertex. It's always going to be x equals, and then its coordinate will match the x-coordinate of the vertex, so 3/16. All Alright, complete the square to find the vertex. So if we have an equation in standard form, one way to find the vertex would be to complete the square. And let's see. Okay, so first thing we need to do, let's move the c to the other side. Okay, so I'll subtract 8. Minus 12x. Okay, and then factor out a 3. All right, I want that a term to be a 1. And then I need to figure out what I need to add to complete the square. All right, so it's your b divided by 2 squared. So that's negative 2 squared, which is positive 4. All right, and really that's a 4 times the 3 that's outside the parentheses, so I've really added 12 to that side of the equation. So to keep that equal, I would need to add 12 to the other side. Okay, so I have f of x equals, or I'm sorry, f of x plus 4, okay, 12 minus 8, equals 3 times x squared minus 4x plus 4. Okay, now I can actually do the completing the square. So I can factor this as x and x, 2 and 2, and then looks like I need 2 minuses. I either need two positives or 2 negatives, and since my term in the middle is negative, looks like I need 2 negatives. Okay, rewrite that as x minus 2 squared, and then finally move the 4 to the other side. So it was added, so I'm going to subtract, and now minus 4. Alright, and now that this is in vertex form, it would be easy to find the vertex just by looking in the right spot. Okay, so my HK, or my vertex, is a 2, negative 4. And that's the vertex. Alright, what if I have standard form and I need the zeros of the function? Right, what if I need the zeros? Alright, so I know how to factor this, and that's one way to find the zeros. Alright, x and x. I can do 5 and 1, both positive, and then 5x and 1x does add up to 6x, so that looks like it will work. Alright, so the zeros would be, in other words, when the y-coordinate is a 0. And then I can use the zero product property to say that either x plus 5 is 0 or x plus 1 is 0. And so x equals negative 5 or x equals negative 1. Okay, so now that we have the zeros, we can also find the vertex. Alright, and here's how we'll do this. We're going to use symmetry properties. So let's look back at the graph of a parabola. Alright, notice that the zeros, because a parabola is symmetric, your zeros are going to be the same distance away from that axis of symmetry, and that axis of symmetry is lined up with the vertex. So in other words, what we're saying is the vertex is halfway between the two zeros. Alright, well, how do we find something that's halfway between two numbers? Well, we average those two numbers. Alright, so if I take the x-coordinates for my zeros and average them, that's going to help me find the point that's halfway in between. So negative 6 over 2 or negative 3. Alright, so we're talking about x values here, so this is the x-coordinate of the vertex. And then to find the y-coordinate, I just need to substitute this back into the equation and solve for y. Right, so in other words, I want to find f of negative 3. Okay, so I've got negative 3 squared plus 6 times negative 3 plus 5. and that's 9 minus 18 plus 5, which is negative 9 plus 5, which is negative 4. So my vertex is negative 3, negative 4. All right, so that's the brief overview, some more additional examples of finding the key properties of quadratic functions and the connection between the equations and the graph of a function.